An object the size of Manhattan tears into our solar system at 130,000 miles per hour. Its name is 3I Atlas, only the third confirmed interstellar visitor in recorded history. But this isn't just another chunk of rock drifting across the void. To the world's top astronomers, it is something more unsettling, because the data suggests that Atlas does not behave as a simple comet should. Tiny deviations in its acceleration whisper of possibilities far beyond natural explanations, hinting at propulsion, control, or intent. The whispers began quietly, buried in the fine print of measurement logs, but they soon grew into speculation that few dared speak aloud. Could 3E Atlas be more than a frozen relic from another star system? Could it be a nuclear-powered reconnaissance craft, threading its way through the inner solar system with precision that defies chance? Experts caution against jumping to such conclusions, but the numbers they debate are not the stuff of fantasy. The probability of its exact trajectory occurring randomly has been placed as low as 0.05%. That figure alone has kept the conversation alive, forcing even skeptics to wonder if this immense body is more than it appears. And here, on Lamora, we step into that unfolding debate. We will explore the meticulous observations, the extraordinary claims, and the cautious rebuttals that shape our understanding of this mysterious traveler. From acceleration data that ignited the first spark of suspicion to the haunting possibility of a deliberate mission from beyond the stars, 3I Atlas challenges everything we thought we knew about what moves among the galaxies. The first clue lies hidden not in speculation, but in precision. The story begins with astronomers staring through telescopes night after night, measuring fractions of arc-seconds with relentless discipline. The stakes are nothing less than cosmic, because if the deviations are real, then this visitor is not just another interstellar wanderer. It may be the most profound encounter humanity has ever witnessed. Precision matters when the stakes stretch across light years. The earliest hints of unusual acceleration in 3I Atlas did not come from wild speculation, but from the relentless routine of astrometric measurement. Each night, observatory teams in Chile and Hawaii aligned their telescopes with reference stars, recording the object's position with timestamps accurate down to the second. To the casual observer, these were faint streaks of light barely noticeable against the cosmic backdrop. But to astronomers, every pixel carried meaning. The Atlas telescope's CCD arrays, carefully calibrated against field standards, captured those streaks as 3I Atlas swept across the sky. These images, cross-checked with Pan-STARRS follow-ups and Hubble's razor-sharp snapshots, formed the backbone of the official dataset submitted to the Minor Planet Center. From thousands of points, astronomers pieced together an ephemeris, a precise map predicting the object's path hour by hour in the weeks after discovery. The process hinges on residuals, those tiny differences between where the comet should appear if guided solely by gravity and where it actually did. Each deviation, measured in fractions of an arc-second, was a test of celestial law. If something beyond gravity was pushing Atlas, those patterns would emerge here, a drift, a kink, an offset that grew with time. But no such pattern survived scrutiny. At the millimeter-per-second squared level, the deviations dissolved into noise. Orbit solutions from JPL's Horizon system and the Minor Planet Center aligned perfectly with gravity alone. Adding a thrust parameter or simulating jets of gas failed to improve the fit. Every night, technicians combed through calibration files and error margins. They checked astrometric overlays, examined outliers, and asked whether each odd point was a cosmic ray, a background star, or simply a tracking glitch. After exhaustive review, the verdict was clear. So far, Atlas's motion could be explained by known gravitational influences. Yet, in science, absence of evidence is never final. New data would arrive, telescopes would keep watching, and the faint possibility of hidden propulsion still lingered in the silence. As 3I Atlas drew closer, the debate within the astronomical community sharpened into two camps divided by a familiar fault line. One side pointed to the traditional physics of comets, volatile ices warming under the sun's rays, erupting into jets of gas that nudged the nucleus off course ever so slightly. In this view, every twitch of motion could be traced to carbon dioxide or water vapor bursting from beneath the surface, pushing the comet along like a slow, invisible thruster. The numbers supported the possibility. Just a few kilograms of gas released each second could account for millimeter per second squared accelerations, if such deviations were real. And yet, when scientists turned to the latest photometry and spectroscopy, they found no smoking gun. The coma was visible, yes, glowing faintly in a predictable haze. But clear jets? Unresolved. The tail? Consistent with sunlight-driven dust release, not with the kind of asymmetric propulsion a true engine would require. On the other side stood a handful of theorists, led by Avi Loeb, who argued that the absence of obvious outgassing, combined with Atlas's brightness and uncanny trajectory, left open a far more radical explanation. Loeb floated the possibility of a nuclear-powered propulsion system, bold enough to rival science fiction. His calculations suggested that a gigawatt-class reactor, theoretically, could provide the thrust and luminosity observed, positioning Atlas not as a natural comet, but as an engineered probe. The implications were staggering. A probe threading planetary flybys in sequence, propelled by controlled power, would mean intent, purpose, observation. But NASA's comet specialists pushed back firmly. If such a system existed, they argued, it would unleash detectable gamma rays, neutrons, and infrared heat. Instruments on Earth and in orbit searched for those signals. None were found. Instead, Atlas's brightness and thermal profile matched dust and ice reflecting sunlight, entirely natural, frustratingly ordinary. Still, the mystery lingered. Extraordinary claims demand extraordinary evidence. And while the case for a nuclear drive was unproven, the rarity of Atlas's path, its scale, and the silence in the data kept speculation alive, hovering at the edge of possibility. Numbers alone cannot capture the awe of Atlas's scale. Astronomers estimate its nucleus stretches nearly 20 kilometers end to end, an object with the bulk of Manhattan Island, but hurled through interstellar space at more than 130,000 miles per hour. Imagine the lattice of skyscrapers, avenues, and riverside parks, not anchored to Earth but cast adrift in the void, indifferent to gravity wells and planetary orbits. This was no pebble, no fragile snowball. It was a city-sized mass, a silent juggernaut slicing across the solar system. And yet, for something so vast, Atlas arrived as a ghost. Its approach vector, angled dangerously close to the sun's glare, kept it hidden from sky surveys until it was already well inside the inner solar system. Even the most sensitive telescopes could not clearly define its outline. Early images revealed only a swollen glow, a coma of dust and gas blurring the true body within. Astronomers were forced to peel away that shroud pixel by pixel, modeling reflectivity, subtracting background stars, estimating albedo with wide margins of error. Even under those uncertainties, the lower bound was staggering. At least 15 kilometers across, perhaps larger. If set beside Manhattan, its shadow would swallow the borough whole, stretching from Battery Park to Harlem, dwarfing every human structure beneath it. For comparison, Oumuamua, the first confirmed interstellar visitor, was barely the length of a football field. Borisov, the second, was the size of a modest mountain. Atlas eclipsed them both, a new benchmark for what it means to be interstellar. Its arrival forces a reckoning. How many giants like this slip through unnoticed, masked by cosmic geometry, revealed only when fortune and vigilance intersect? Detection was luck as much as skill. Automated surveys like Pan-STARRS and Atlas barely caught it in time. The lesson is sobering. The universe is not empty. It is teeming with wanderers. And some are so massive that their presence challenges the limits of imagination, reminding us how small our world truly is. Among astronomers, the signature of an interstellar traveler is unmistakable: a hyperbolic orbit. Unlike the closed ellipses that bind planets and comets to the sun, a hyperbola is open. An arrow cutting through the solar system, never looping back, never repeating. For 3 Atlas, the numbers are unambiguous. Its orbital eccentricity exceeds 1.005, a mathematical guarantee that this body is not a native of our star's family, but a visitor from the deep beyond. It entered at nearly 61 kilometers per second, around 137,000 miles per hour relative to the sun. Even stripped of every assist, that speed alone was enough to clear the solar escape velocity. Once Atlas completes its sweep past the sun, there is no leash to draw it back, no orbit to trace again. Astronomers calculate that its outbound velocity, its v infinity, will remain a staggering 26 kilometers per second. That ensures not only its escape from the sun's grasp, but also from the Oort cloud itself. Beyond that boundary lies nothing but the unbroken dark of interstellar space. Visualize the path on a solar system map, not a loop, not an ellipse, but a spear slicing across planetary orbits. The sun bends it, but cannot bind it. Even Jupiter, the heavyweight of planetary gravity, will only nudge its course slightly, unable to capture or tether it. This defines the urgency. Atlas will spend only months inside the orbit of Mars, only a few weeks at Earth's distance from the sun. Then it will accelerate outward, forever diverging from the star that momentarily illuminated it. Every observation, each spectrum, each frame of data is precious, because there will be no second chance. The same orbital mechanics that prove Atlas is not from here also guarantee it will never return. For astronomers, this is both a scientific challenge and a poetic reminder. A visitor arrives once, silently, then vanishes. The responsibility is ours to see, to measure, and to learn before the darkness swallows it again. If Atlas's size and velocity astonished astronomers, its trajectory left them speechless. This was not a random plunge through the solar system. Its hyperbolic path threaded a sequence of planetary flybys so improbable that simulations placed the odds at less than 0.005%. To many, it looked less like chance and more like choreography. The itinerary reads like a mission plan. On September 30th, 2025, Atlas will sweep within 13.9 million kilometers of Mars, close enough for orbiters to track its coma and perhaps even glimpse its hidden nucleus. Just 2 weeks later, on October 14th, it races past Earth at 27 million kilometers, outside the Moon's orbit, but closer than any interstellar visitor humanity has ever recorded. Venus follows on November 2nd, with a flyby at 27.2 million kilometers, its cloud tops gleaming in the sunlight. Finally, on March 8, 2026, the object brushes past Jupiter at a distance of 22.4 million kilometers, a final encounter before it accelerates outward into the void. Each approach is timed with eerie efficiency. At Mars, the geometry favors surface illumination. At Earth, the vantage point aligns almost perfectly for near-side observation. Venus, with its reflective clouds, offers contrast-rich imaging conditions. Jupiter, with its storms and magnetosphere, becomes a natural finale. To planetary scientists, these encounters are golden opportunities to study not just the visitor, but the planets themselves from a perspective rarely granted. To others, the pattern suggests intent. A reconnaissance craft would want maximum coverage with minimal risk, slipping past worlds at just the right angles. Avi Loeb and his colleagues argue that the geometry is too efficient to dismiss. The flybys resemble a survey route, optimized for observation and escape. Skeptics counter that in a universe of countless objects, even rare alignments must occasionally occur. But the statistical improbability keeps the suspicion alive. What is certain is that no other interstellar object has ever traced such a path. Whether coincidence or design, Atlas's planetary tour is one of the most extraordinary sequences in the history of solar system astronomy. Each pass of Atlas through the inner solar system sharpens an unsettling question. Is this path simply the outcome of chance gravitational dynamics, or does it hint at intent? Its trajectory, skimming Mars, Earth, Venus, and Jupiter in sequence, resembles less a random drift and more a survey. Here, the dark forest hypothesis, once confined to speculative fiction, finds a haunting echo in real data. The theory envisions the universe as a dangerous forest, where every civilization is both hunter and prey. To survive, one must remain hidden. Any flare of signal, any evidence of presence risks destruction from unknown others. If intelligence wished to observe without revealing itself, it might send probes that glide silently past planets, gathering data, then disappearing into the dark. Atlas, in this light, becomes more than an icy mass. It becomes a possibility. Avi Loeb draws a direct line back to Oumuamua, the first interstellar object confirmed in 2017. Oumuamua's elongated shape, its unexplained acceleration, and its silent passage sparked furious speculation. It was small, barely a football field in length, yet mysterious enough to ignite debate about artificial origins. Now, less than a decade later, Atlas arrives. 20 times larger, more luminous, and threading a planetary sequence far more dramatic. The coincidence of timing, an 8-year gap between visitors, feels to some less like randomness, more like escalation. First a scout, then a more capable probe. Such speculation bleeds into realms beyond astronomy. Strategic think tanks whisper about surveillance. Security analysts debate whether silence or communication is wiser. Some invoke the dark forest logic, urging caution, insisting that even curiosity could be fatal. Others feel the pull of connection, the chance to reach beyond our isolation. If Atlas is more than a comet, then the implications stretch beyond science into the destiny of humanity itself. For now, evidence remains elusive, but the question lingers. In the vast dark, are we truly alone, or have we already been noticed? Spectra and imaging tell us part of the story, but not the whole truth. When Atlas first crossed into the outer reaches of our solar system, its coma, the cloud of dust and gas surrounding its nucleus, was already visible, glowing faintly in regions where most comets remain silent. That early activity puzzled scientists. Chemical analysis revealed a composition rich in carbon dioxide, with an 8-to-1 ratio compared to water. Most comets in our solar system show the opposite, suggesting that Atlas was forged in a colder, more distant nursery around another star, where carbon dioxide ice could survive for billions of years. Photometric models supported the idea of a natural comet, sunlight scattering off dust grains, brightness levels within expected ranges, a tail extending millions of kilometers, pushed away by solar radiation. Nothing in the data shouted artificial. No persistent jets, no unnatural emission lines, no hidden reactor heat. To NASA's comet experts, this was the strongest evidence that Atlas was exactly what it appeared to be, a remarkable but natural visitor. And yet, the doubts endure. The trajectory remains an outlier. The sequence of flybys still defies the odds. The silence of high-energy instruments leaves space for speculation. Engineers at ESA and NASA admit that even if Atlas were an artificial probe, our technology might not be sensitive enough to prove it. Project Lyra's failed attempt to design a feasible intercept mission underscores the frustration. By the time humanity recognizes the opportunity, the chance to act has already slipped away. So what remains are questions. Should we interpret Atlas as a messenger, a scout, or simply a frozen relic of another world? Do we dare to speak into the void, or is silence the wiser path? These are not just scientific puzzles, but existential choices woven into the story of a single interstellar traveler. Here on Lamora, we are reminded of what Atlas leaves behind, not answers, but possibilities. A call to vigilance, a challenge to imagination, and above all, a reminder that the universe is still full of mysteries, vast enough to humble us, fleeting enough to demand that we pay attention.